Hey guys, welcome to lesson 6.3. Today we're going to talk about Introduction to Rational Functions. Our objective today is to explore some characteristics of rational functions. So a rational function is just a function that's in a ratio form, meaning it is in a fraction form and it's dealing with these variables. So our first example that I want to look at today is to consider this rational function given by f of x is equal to x plus 6 over x minus 3. Algebraically determine the y-intercept. So what we need to remember is that your y-intercept is when your x value is equal to 0. So another way I can rewrite this, remember f of x is the same thing as me writing y. So when is x equal to 0? So I can make this as y equals 0 plus 6 divided by 0 minus 3, which I can go ahead and simplify, oops, that's a 3, as negative 2. And this is my y-intercept. Now, what if I say find the x-intercept? Your x-intercept, in this case, would be when the y is equal to 0. So I will have 0 is equal to x plus 6 over x minus 3. If I was to cross multiply here, I would get 0 times x minus 3 is equal to x plus 6. 0 times anything, I know it's 0, so it's x plus 6. And how would I solve for x? So what would I do? Minus 6 on both sides. And then I have minus 6 is equal to x. So my x-intercept, is at negative 6. Now this is another recap. It says find what value of x is the function undefined. So remember, undefined means when my denominator is equal to 0. So my denominator in this case is x minus 3 is equal to 0. Why do I set it equal to 0? Because I want to find what value of x when I plug it in would give me 0, because I cannot divide by a 0. So in this case I will add 3 on both sides. This is cancel. X equals 3. Now knowing this here, x equals 3, how can I write a domain in set builder? Remember, I'm asking specifically for set builder notation. So it means x such that x cannot be equal to 3, because when x is equal to 3, this up here becomes undefined. Okay, so these are all things that we talked about before. It's just a simple recap. Now it says, find all the values of x for which the rational function h of x, all of this, is undefined. That's my keyword again. Verify by using a calculator for these functions. So you have two options. You can graph this in the calculator and look at when it intersects the x-axis, but I want to do it algebraically. So I know, because undefined it means when is 2x squared plus 11x minus 6 is equal to 0. They have nothing in common, so my a is 1, my a is 2, my b is 11, and my c is negative 6. So this becomes negative 12, 11, and my two numbers now are going to be positive 12 and negative 1. Now remember, a is bigger than 1, so I have to do the special part where I replace this middle term. I will end up getting 2x squared plus 12x minus 1x minus 6 equals to 0. So I want to look for what these have in common. They have a 2x in common. I'm left with x plus 6. These have nothing in common, and I am going to be negative 1. Then x plus 6 equals 0. So again, remember, I look at what these two have in common, and then what these two have in common. Now that I see that I can rewrite this once, and then I take the outside and I write it again. Now I have this. I want to see what are these values. So I'm going to just come up here, and I know it's x plus 6. When is that equal to 0? Minus 6 on both sides. X is equal to negative 6. That's one of my answer. And I want to do the other part. When is 2x minus 1 equals to 0? So this becomes 2x is equal to 1. X is equal to 1/2. So at these two values, x equals 1/2 and x equals negative 6, this rational function is undefined. So moving it to exercise 3, similar question, which of the following represents the domain of this? So again, the domain would be every number except when this denominator is undefined. So I want to find those values. So this becomes x squared minus 6x minus 16 is equal to 0. My a is 1, my b is negative 6, and my c is negative 16. So if I was to do my x method, this becomes, what are these values? So the values will be negative 8 and a positive 2. I will write x minus 8 and x plus 2 is equal to 0. I can just write it like this because my a is equal to 1. So I want to break this down. X minus 8 equals to 0. So that means x is equal to 8. And my other option is x plus 2 equals to 0 minus 2 on both sides. X is equal to negative 2. So knowing these are my two answers, that cannot be included in the domain because that will make my denominator undefined. So it will be choice number 3. Okay, moving along, we have example 4. This goes back to unit 1 where we did composition of functions. So refresh your memory. We always work on the inside, then the outside. So the first thing I want to do is g of negative 2. I'm using my g function. Wherever I see x, I'm replacing it with negative 2. This works out to be negative 8. And then I want to go find f of negative 8. So this becomes 2 times negative 8 plus 1 over negative 8 plus 5. You put this identical in the calculator, you should get your final answer as 5. Let's try one more. Remember, work on the inside first. So this is g of 2, which becomes 3 times 2 minus 4, minus 2, sorry. 3 times 2 minus 2, which is 6, is 4. Now I want to find f of 4. 2 times 4 plus 1 over 4 plus 5. Put this all in your calculator, you should get 1. Remember, all we're doing, wherever we see x, we're just replacing it with those numbers. Now this one, it was the hardest one that we had to do. Find f of g of x. So first, we do the inside. G of x is actually 3x minus 2. So now, I want to find f of 3x minus 2. So in the previous example, we bring the 4 down, and then we substitute in that function. Now the same thing is going to happen here. We're going to use this f of x function, but wherever I see x, I'm going to replace it with this entire thing. So where I say 2x, I'm going to have 2 parentheses 3x minus 2 plus 1 over 3x minus 2, and I'm going to keep it in parentheses, plus 5. So what I want to do is distribute this over first. Get rid of my parentheses. So 3 times 2 is 6. This becomes 6x minus 4 plus 1 over 3x, and I'm going to combine minus 2 plus 5 is a positive 3. So I'm just going to move these over here so I have a little space to finish this. So now what I want to do is just combine like terms. This becomes 6x minus 3 over 3x plus 3. This is my final answer. One thing that I want to point out, when you see an x, this just means that your answer will have an x. Okay? Like this word numbers, it means your final answer was all numbers. Now in this case with the x, it just means that your answer will get an x inside. Okay? So number 5, this is those inverses that we talked about back in Unit 1. There were 4 steps that you need to follow. So let's try these. Okay, so let's look at the first one, and hopefully we remember these steps. So I will go through step by step for these, and then you follow. So step 1, it says replace f of x with y. This is done already. Step 2 says switch the x and y. So let's do step 2, where this becomes x is equal to y over y minus 2. I'm going to kind of write all over and then take it away, so please copy as we go along. Step 3 says solve for y. So how do we solve for y? So in this case we need to cross multiply. I get x y minus 2 is equal to y. Remember, this is the same thing as x over 1. So if I cross multiply, y times 1 is just y. Now I want to go ahead and distribute. I get xy minus 2x is equal to y. I want to combine all my y's together. So I'm going to bring this y over and take that over. So this becomes xy is equal to y plus 2x. Now I'm going to take the y over. xy minus y is equal to 2x. Now looking at this, they have a y in common. This becomes x minus 1 is equal to 2x. And then remember, this is multiplying, so I want to do the inverse, which is x minus 1 dividing by x minus 1 on both sides. That's my inverse. When I do that, this is cancel, and I'm left with y is equal to 2x over x minus 1. And this is my inverse. So there are 3. The 4th step was actually step 4 is replace, not a y. Replace y with f inverse of x, but we don't have that in case, so this is really not necessary. So this is my final answer. I want you to pause the video and try number 2, well, B and C on your own, and then let's know if we get the same answer. So now that you got a chance to try this, I hope for B you got y equals 3 over 2x minus 1. If you did, great job. Now let's check out C and D. So for C, you should have gotten minus 1 minus x over x minus 1. And then for D, the last question, we got y equals minus 1 plus 4x all over x minus 2. Alrighty guys, there's our look for 6.3. Now go ahead and work on those problems. Don't give up. I know we've done this before a long time ago, but now is the time for you to refresh your memory. See ya!